Welcome to solverfy.
Right. When we look at isomers, structural isomers, we're looking at compounds that all have the same number of carbon and hydrogen, so the same chemical formula, but they have different structures and therefore different names. So if we look at C6H14, we are going to look at C8H18. If we look at C8H18, we're going to see that we have many different isomers that we can draw. We are going to focus on the hexane, or the 6 carbon, and the pentane, which are the 5 carbon chains. Right. So here I have some 6 carbon chains drawn. Just as a reminder, when we draw this line structure, we get 2, 3, 4, 5, 6 carbons. And we're going to pretend, or we're going to number them 1 through 6. We're going to number left to right. Okay. And that's just convention. You can number right to left, but just make sure that you're keeping track of what you're doing. Right. So at this point, when we draw these structures, we have 6 of the carbons filled in. When we draw the line structures, we're assuming that all of the appropriate hydrogens are attached. So every carbon has 4 total bonds, whether they be to carbon or hydrogen. Right, so that's 6. So when we look at this top one, okay, if we add, let's say, 2 more carbons on here, let me try it again. If we draw 2 more carbons on there, 1, 2, CH3 groups, right? Those are both on the second carbon, so that would be 2,2-dimethylhexane. Okay. All right, another option would be to put 1 on the second carbon and 1 on the third carbon. Oop, that's wrong, sorry. 1 on the second carbon, 1 on the third carbon, okay, which would be 2,3-dimethylhexane. Okay, you can see a pattern here, I think, right? We can also do second and fourth, right? So that's 2,4-dimethylhexane. We could also do 2,5. So that's 2, 3, 4. This is 5. So that's 2,5-dimethylhexane. Okay. We could do 3,3-dimethylhexane. We can do 1, 2. We can do 3, 4-dimethylhexane. Right, and then our last option is to actually put an ethyl group, so a 2 carbon chain in here. So if we do that, in order to make this make sense, it does have to be on that third carbon in order to keep the 6 carbon chain in place. Right? If we put it on carbon 2, then we would change the chain. So we want to put an ethyl group. Okay, you can kind of draw it as we got that 1 carbon here, right, and 1 carbon here. So that would be 3-ethylhexane. Right, when we go to the pentane groups, right, we see the same kind of thing. So I have our 5 carbon chains drawn here. Right, we're going to do the same sort of thing, but now we have to add 3 more carbons on to get that C8H18 structure. Right, so we can do all sorts of combinations. We can do a 2,2,3. We would call that 2,2,3-trimethylpentane. Right, we can do a 2,2,4. We can do a 2,3,3. Right, so all sorts of combinations. We can do a 2,3,4. We can do a 2-methyl, 3-ethyl. Okay, so just like before, we have a 2 carbon chain coming off of that. Oh, sorry, that one's, let's back that up. Let's put that on the third carbon. There we go, that's better. So 2-methyl, 3-ethyl. Okay. We can put them both on 3. We can put a methyl and an ethyl there. Right, so that would be 3-ethyl, 3-methyl pentane. Right, so all sorts of options for those C8H18 isomers.